So this is Jean, and I will start the tutorial for the outdoor thermal comfort analysis. So I talked about UTCI yesterday to analyze the outdoor comfort. And what we need is we need to look at like where the UTCI component is. So under the analyze data, you can find the UTCI comfort. So yeah, here that we can look at the inputs: air temperature, mean radiant temperature, and relative humidity, wind velocity. Those are something we consider to calculate UTCI. So then let's look at the air temperature. Yesterday I said the air temperature can be same with the driver temperature, meaning that we need to bring the weather data. So we can bring the driver temperature to here, and it says we need EPW file. So then let's go to the EPW map, toggle, connect, enter. This assignment will be based on the Philadelphia. So Philadelphia, we are doing the assignment for the campus, which is around here. The closest EPW file will be the airport data. There are two TMY3 data available. They are the same, but I will download the DOE file. So I copied the URL address to my clipboard and so now I have the URL file. Yes, URL address, and then I will import the weather data. I can use this component to bring the EPW file here. So it's easy because we've done it so many times. So let's look at the UTCI values for Philadelphia in general. We need like mean radiant temperature, but let's leave it as default for now. And we need relative humidity. And we need wind velocity, but as I said in like the earlier lectures, the wind speed in the airport are like much faster. So I would like leave it at just like default, which is 0.5 meter per second. So you can also consider like considering increasing the wind speed, but I will leave it as it is for now. So that another toggle to run the UTCI analysis. And yeah, it's not in orange color anymore. And let's see what the data looks like. It's saying, oh, it has like 8760 values, but it's not really visible. So let me bring the hourly plot to see like what the data look like. So, okay, comfort data for UTCI is, oh, let's look at the UTCI value first. So UTCI value, it has the like temperatures in Celsius. So it looks very similar to the dry bulb temperature chart. Then what is the difference? Let's take a look. Dry bulb temperature, and then they are overlapped. So I will make a point here, and then apply here and use it as base point. So this is dry bulb temperature as shown here, and at the bottom is UTCI. So that's how you tell like which one is which one. And if you look at the data, they look very similar. I guess like this Philadelphia area is not really affected by the like humidity. Maybe the humidity is not really like changing over time dramatically, but I think like some part that looks slightly different. So definitely they are not the same charts, but they look very similar. And as I said, like UTCI has broader comfort range. So it's from 9 degrees to 26 or 7 degrees. If I remember correctly, if I don't remember it, I can hover over the output. And then, okay, in this category, 0 means no thermal stress. So you don't feel like it's not cold. So it's not cold and it's not hot at all. Then the temperature for that category is between 9 and 26. So that you want to bring the outdoor temperature within the range. As I said yesterday, the UTCI assumes that we can change our clothes level like as we want it. So it's very like broader range already. So I would like ask you to bring the temperature, I mean the UTCI temperature within the like no thermal stress range. So let's look at the category. Then you might see the difference. So in Philadelphia, there are not many times like that have extreme heat in terms of UTCI analysis. And it's already pretty like comfortable because the yellow means very comfortable. But if you look at the June to August, maybe the lunchtime, which I'm asked you to make comfortable, it's not really comfortable. It has some like moderate heat and not strong heat, but a lot, but like few of the hours have like moderate and strong heat. So I want to bring these hours to no thermal stress hours, as many as possible. So this is the basic for the UTCI value, but what I asked for the assignment is like considering the context of the like buildings around it and also the context of the occasion, which is like there for people are eating lunch all together. So let's see how we calculate the mid-radian temperature for UTCI that accounts for the surrounding buildings and also so the solar radiation. Yeah, let's see, because like this, I said we need to consider the solar radiation. So that's why I suggested to design a shading. But this one, there is no input for solar radiation. Then let's see what we can do. And here, so these are the thermal comfort models that I talked to yesterday. Like PMV comfort, adaptive comfort, UTCI. If you look at the icons, it tells like what they are about. So just briefly, PMV, that is for indoor, and mostly people did the experiments for sedentary behavior. So the person is sitting there, it considered the temperature and humidity, like in indoor. So that's what the icon tells. And this one is adaptive comfort. It doesn't take the humidity into its account. So that's why it doesn't have the water drop, but like still has the dry bulb temperature icon. And so like the person is inside, but the activity is not limited to the sedentary behavior. And last one is the UTCI for outdoor value. So this one doesn't have the like boundary, but it takes the temperature, humidity, and solar radiation into its account. So if you are confused, then you can look at the icons and then remind yourself like what they really means. And here there is like mean radiant temperature for indoor, but now we are running the mean radiant temperature analysis for outdoor. So we can bring it down. And for inputs for outdoor solar mean radiant temperature, location, and surface temperature, that's we have no idea. So if we hover over the input, is that a single number or an hourly data collection with the temperature of surfaces around the person in degrees Celsius. This includes the ground and any other surfaces blocking the view to the sky. Typically, outdoor driver temperature is used when such surface temperatures are unknown. So if you think about the benches in front of males now, there are some wooden benches, so they may have like warmer temperature compared to the concrete walls, especially in like this season when it gets colder. So all the surfaces have different temperatures and they're emitting different level of energy. But at this point, we haven't learned a lot about like the energy emission from the surfaces. So we can just assume it has the same temperature with a dry bulb temperature. And here what we need is the data about the sun. Because like the pregens were absence of the sun matters a lot in terms of the solar radiation. So that's why in the photo I showed you yesterday, between the male seminar and the fine art library, there were people like more sitting in the shady area compared to the like sunny area. Maybe if the weather gets even colder, we may see more people in the sunny area because they want to absorb more heat from the solar radiation. So that's how the solar radiation matters in the thermal comfort. And this one says direct normal solar irradiation. So direct solar radiation and horizontal diffuse horizontal radiation, and this one is horizontal inflared, so you need to skip the global one. This one here, and we need another toggle to do the analysis. Yes, so now is in gray color. Okay, then let's see what is the input for mean radiant temperature. And yeah, this seems to be correct. And so this is the graph for the mean radiant temperature. And this is graph for the UTCI in general. And I will make another graph for the MRT. And of course, we need another point to separate the charts. Right. Yeah, so these are in Celsius. And so this one is not considering the solar radiation because the dry bulb temperature will be captured like in some shaded area, but this one is capturing like how hot or how cold it is, like considering the solar radiation. So this is the big difference that we can really tell. So if we run UTCI analysis with this mean radiant temperature, or we make another graph and UTCI, let's look at UTCI and then separate it again. Okay, so there are, I will just make it the UTCI for now. So the first one is dry bulb temperature. Second one is UTCI, but those are not considering the sun. And this one is mean radiant temperature that is considering the solar radiation. This one is the UTCI. So this is the UTCI you want to bring it down because the side that I gave, the like front area of the Mayor's Hall, that doesn't really have a lot of shading. So it should be very similar to this one. And if we look at the like comfort category, like in June, July, August, it doesn't have a lot of like hours of comfort. So these are like the target points for our analysis. I mean, you can also do some like some position study to like figure out, oh, how I need to design the shading to block the sunlight, something like that. But that's what we've done already. So I'm not gonna do that here. So this is the basic UTCI values. But then we need to consider the shading that we design, and we also need to like bring people's behavior into this model. So that let's start to bring the solar body temperature parameter. No, solar body parameters. Okay, so here we have different parameters about the human for PMB comfort, adaptive comfort, but we're going to use the solar body parameters. Okay, so we will use this one as like a sensor for the mean radiant temperature analysis. And here we can also find a solar body parameter. I guess it has some default value, but we can like still like make our own and then make the analysis more accurate. So let's look at this component. It has posture, chart, and body, add something, and then these, but I will only use the posture because if you hover over this one, the default value is standing. But I asked you to provide a comfortable space for people who are eating lunch. I mean, some people may eat lunch while they are standing, but in general, people usually sit down. So I just type seated and make it as input and bring this one. It's slightly changed. Doesn't matter a lot, but yeah. Still like it had a little bit different. So this is how you take the like body position into its MRT model. But then we still need the like geometries of our surrounding. Then we go to the analyze geometry, human to sky relation. Here, this one will tell this components where the person is, because like up to here, it doesn't have any like contextual data. This one, no sun, these have the solar radiation, but it doesn't have any data about the like contexture. So I will upload the let's just start from here and make a surface. So let's assume this is the surface you're testing. And let's say there is a vertical surface. Is this vertical? Okay, this is vertical. And let's see. So we need location. We need position of the person. What we can do is remake like point. That's the easiest one. So make a point. Somewhere here, and then put input for that, and then put the position for the person. And in the context, I will make a B-rep, and then this one, not the curve. Bring the multiple B-rep into its context. So, and then run. So this is like about the human's position. And if you look at the height, the number for the height of the person subject in the current random model unit is default is 1.8, just like leave it as it is and run. And let's see what the values are. So maybe we can use preview to look at where the person is. So this is the meter point, and this is the body. And this is fraction of body exposure exposed to direct sunlight. So this tells like in every hour how the body is exposed to the solar radiation, and it will change the mean radiant temperature outside. So we will use this one over here, and also like sky exposure, how much the person is like exposed to the sky. So now we have new values. And now maybe we can compare what is the difference between the data with the context and without the context. So I will disconnect these. I will just leave the body posture the same. Put it here. So I need more points. Copy. And points here. The points here. Okay. So, okay, this didn't help a lot because like the chart looks very similar. Okay, then what if I move this one? Let's just like put this surface here and then see when the sun is blocked, what happens. So the sun is blocked, the graph should have been recalculated. So that is only like vertical surface, so it didn't really help, but we can tell since blocking the sunlight from south, we have more hours of comfortable condition. So then let's try something else like perspective. I didn't mean this perspective. Okay, I'll make this one to top and this one to perspective. Okay, so these are the charts. Let's change this one a little bit, rotate, center point. Rotate 3D, center point. Rotating axis is this one, and then maybe rotating like 20 degrees. And let's see whether it helps. I think now it has more yellow, which means the comfortable hours. So if I go back, then redo. Did it help? Yeah, I think it helped a little bit. It got rid of some like heats. So it's definitely not gonna be your shading design, but you will compare the chart for for the like UTCI value, like with and without the shading. And you will also consider looking at the like categories and UTCI at the same time. I don't know, it depends on your strategies and your intention. So this is UTCI value and category. You can like take a look of the UTCI value briefly, and then the target you wanna hit is the comfort range in UTCI, which is between 9 and 26. So I think there is a way to like count the hours of the like, let's see the categories. I don't know why it doesn't have all the detailed values, but let's try something like this deconstruct data. Values, okay, it has values. So you can count how many hours you have the zero value for a category of UTCI, which means the no thermic stress. Okay, with this component, you can do that. And what I asked to improve is the lunch time during the summer. So in this assignment, I will assume the summer is between June and August. So from June 1st until August 31st. So that's the target. And for lunchtime, I will ask you to run the analysis between 11 a.m. till 2 p.m. So it's like 3-hour window for 3 months. I think like you know how to filter out the data with the like analysis period. Oh, maybe not this one. Due date time. Not calculate. What is it? The one. Okay, so this one. You can put like month, June 1st, August 31st, and you can put the period. So actually you don't need to run the annual analysis, but I just wanted to show like how you generate all the charts. And you can also like count how many like zeros you have. You will find your own way to calculate it. And so I think it's enough tutorial for you to do the like assignment. And if you have any questions, you can always email me and I will let you work. So thank you. Bye.